Hi everyone, my name is Kizamba Kenneth and I'm here with my colleague
Katamba Mark Benjamin. So today we are here basically to present to you EXASCALE computing, and like we saw earlier, EXASCALE computing is to do with high performance computing, or call it supercomputing. So in our case study today, we are dealing with climate and weather, zeroing down to severe weather and climate events forecasting in Uganda.
Yeah, and by severe weather and climate events, he's trying to mean things like heavy rainfalls, things like prolonged drought, and under heavy rainfall, maybe you can talk about things like landslides. Of recent in Uganda, we had issues in Wududa where we had landslides. It was all a cause of heavy rainfall, which is all under things to do with severe weather and climate events. So let's check out this video and we shall be back.
We can see the flooding there which happened in western Uganda. This disastrous kind of flooding happened in Kasese district. This swept away most homes, leading to loss of lives and of course property. Most bridges were swept away, and this has just happened. You can see there it was during a heavy downpour.
10 people have been rescued and admitted at Bududa Hospital.
At the scene, the mood was one of anguish as residents using rudimentary tools dug through mounds of mud in a desperate attempt to rescue their loved ones. It is reported that a good number of the residents were indoors when huge blocks of mud and rocks started to roll downhill, toppling homes, killing livestock and burying people alive. The landslides, they add, were unexpected, occurring several hours after a torrential overnight downpour that at first seemed to have caused little damage.
Yeah, so you realize from that video that severe weather and climate events can be very horrible to an economy like Uganda, you know?
Yeah, and however, with the implementation of EXASCALE computing, or call it EXASCALE computers, as my colleague already said, those are high performance computers with some countries like the US, China, India, exactly. So they're trying to develop some of these high performance computers, so, and all this is being done in order to enhance on how weather can be forecast. Let me say they can be able to predict what will happen in the next 50 or 25 or 10 years to come. And so we took an initiative for you guys. We made this video and we would like you to watch this video, see how these systems are working, what has been implemented, and what are these guys really planning.
The National Weather Service is now offering a first look at two powerful new SuperCom computers. The National Oceanic and Atmospheric Administration says the supercomputers can calculate nearly 4 times more than the old system, and that the upgraded system has already been used to give early warnings for the recent storms in the south. The computers are part of a nearly $45 million project to boost the country's forecasting capabilities. The National Weather Service hopes this upgrade will put the U.S. on par with systems that are currently in use in Europe.
You know, in the case of severe weather, pinpointing exactly when a storm is going to hit, where it's going to hit, and exactly what type of severe weather we're talking about can be critical. Because if you have that information, and if you can get it into the hands of the public, you potentially can save lives.
Well, it's been a busy day.
And at the National Weather Service office in Sullivan, you don't need a calendar to know that spring is fast approaching, because so is the first potential severe weather of the year.
Yeah, there's a bit of excitement in the air because it's our first go at it with thunderstorms.
And determining when, where, and how that severe weather might develop is the job of the meteorologists at the National Weather Service. To do that, they now have a valuable tool, a supercomputer that takes up-to-the-minute data and provides models of where a storm likely is to track and what it might deliver.
We look at this data, and then we convey what we believe the storm threats are going to be. And this high-resolution data, again, will help with the storm type. Is this going to be a linear system, which would be more of a wind producer? Is this going to be a rotational superstorm structure?
And that matters because conveying that message and giving ample warning to communities can save lives. The supercomputer more than doubles the National Weather Service's computing capacity, providing more accurate forecasts in all seasons.
From that, you can see how really awesome the implementation of EXASCALE computing can be in regards to weather and climate forecasting in this country.
but still we have quite a number of challenges in our country, and the greatest challenge is finance. Because apparently the US government invested $43 million in developing one supercomputer for their weather channel. And maybe the other challenge would be
we could have another challenge to do with paperwork. Most of the systems, the system in Uganda in these meteorological centers is most of the work is paperwork, and these systems, exascale computing systems, are built to work on softwares. They use softwares, so there is no way it can be implemented in an environment where most of the work is stored on paper and paper files, you know.
Exactly, and maybe to add on the paperwork, the other issue will be the highly skilled personnel that will be required to manipulate such systems, because these systems require a lot of highly skilled personnel to manipulate them, because they are a little bit complicated than the usual machinery that we are used to. Yeah, and maybe to add on.
Yeah, so basically I would like to say that's what we had for you from the EXASCALE computing fraternity.
Thank you guys for watching.
Thank you for the support. We rest our case.